Okay, so yeah, hello, and welcome back to this series of lectures on deep learning. So, in the last video, we learned about what is a neural network, like all the steps of neural network. Right. We learned about uh, all the steps of building a model, and also we talked about what is a neural network and what is the function of a neuron, what does it calculate, and you also learn about parameters, what are weights or parameters, and how do they affect the output function, and also you also learn about the loss function today. So we are going to cover a wide range of topics. And then first we have optimization, right? So as I uh, mentioned in the earlier video, you know we should update the model's weight such that the loss function is as less as possible, right? I'll just make you memorize it. I'll just make you revise it, right? So right, so we have a model, right, which has some rules, right? So these are parameters or weights. We give the inputs, the model will get us an output, right? So this is o hat, or the model prediction, and then we'll compare this o hat with o, right? So we'll compare o hat with o using the loss function, right? So we'll use the loss function to compare this o hat and o, right? And we want to make this o hat as less as possible, right? So we want to make the loss function or the difference between o hat and o as less as possible, right? So that is the thing that we have covered in the last video. And then in this video I will try to learn about how do we update these parameters, or in the case of a neuron, with some mathematical notation. Sorry. Okay. So in the case of mathematical notation, let's see how we can update w1, w2, and so on, and b, right? So in the case of neuron, we want to update these parameters, right? We have w1, right? So all the parameters, what are the parameters? As I've covered in the last video, the y hat or o hat is equal to w1 x1 plus w2 x2 plus so on plus b, right? So what are the values that we can update? Well, we can update w1, w2, and b, and we want to make this o hat as closer as possible to o. That is the training process I will just covered you. And now let's see what are the formulas. I'll just go in a slightly high level manner, because I'll not dive deep into it, because it is a whole new subject on its own. It might take, to cover it might take a series. I also suggested you a series, a mathematical series by three blue one brown, on calculus. Just if you want to learn more about calculus and how does this slope function works, definitely go check out the series. Or maybe in the future I'll also try to explain it when it is necessary, right? You have to first learn about the intuition, then you can learn the mathematics, right? Right, so we have formula here. So this is o hat, right? And then we have the loss function. Let me just write down all the function that are there. The loss function is equal to, let's say, o hat minus o the whole square, right? Right. So we're just gonna square the term of o hat minus o, right? We are squaring it because we don't want negative values as loss function. And then after that, what are we going to do is we are going to take w1, right? First we'll calculate the derivative of w1, dw1, let's say. So what is dw1 is, this dw1 represent how this w1 changes affects this loss function, right? So the derivative, the main function of a derivative is to say how a parameter will update the output of a function. Here we are going to see how this w1 is going to update this loss function, and based on that we are going to update this w1, right? So we'll calculate the derivative, which is nothing but, you know we have in calculus notation, we'll have dw1 by loss function, right? So we'll calculate the derivative of w1 with respect to loss. Here d is just nothing but derivative, right? So we will calculate the derivative of w1, this parameter with respect to loss function, right? And then we will say w1 is equal to w1 minus L into dw1. I'll just tell you about L in just a minute. So this is L, right? So we have just, right. So we have w1 is equal to w1 minus L into dw1. So as I told you here, dw1 is the derivative of w1 with respect to loss. That is how this w1, how a change in w1 will affect the loss function, right? So it's nothing but just but this slope, right? And then we are going to subtract the dw1, and we also have a new term here, L, which is called the learning rate, right? So this learning rate determines how fast or how big the changes should be, right? For example, let's say our w1 is 1, for example, and let's say we want our w1 to be 2. So let's say the actual function is 2, and then the predicted w1 is 1, and the actual w2 is w1 is 2. Let's so the correct relation is 2, let's say. So this L learning rate defines how fast should we reach to 2. Right. So from 1, how fast should we reach this 2. So this learning rate, if you keep it more, then it's going to change more, right? So you don't want the model to change more, right? So if it changes fastly, it is going to overhit the target, and it's going to fail again. And you also don't want this learning rate to be very less, because if the learning rate is very less, the training happens very slowly. So currently you don't have to worry about this learning rate, because whenever you are building models in TensorFlow, a lot of models are built in TensorFlow. Even research even models that are built in research, all are built with TensorFlow. You don't have to worry about learning rate, right? It'll set its own, right? So that is how we'll update w1. And same for this same thing is going to happen to all the parameters w1, w2, and b also. So that is the overall optimization function. That is what's going to happen, right? So we are just going to update this w1. We are going to subtract a derivative from w1, and how big the change should be is determined by this learning rate. We can just set the learning rate whatever number we want, and maybe in the future I'll just elaborate on this learning rate too. Okay. So now a lot of data in our current world, in our internet, has some very complex features, right? So it's not that there is only it's not that the input is 1 and the output is 2. It's not that for example, if you look at the real world data, maybe if you think about images, there are a lot of numbers, the pixel values, and there are like complex features that our model has to identify. So for this problem, one neuron is not enough. So that is why we call it deep neural networks. Deep neural networks is building deeper and better models that are that can detect more complex features. So that is why they are called deep neural networks. So therefore, um, we can develop a complex structure of these neurons, right, that are connected together, right? And then we have this input layer, we have this output layer, right? So the input layer is these are not called neurons, they are just input values, and we have as many input values as we like. And how about we connect each of these neurons? I'll get to the theory in just a minute, right? So we'll just connect all these neurons, right? The connection means the output of this neuron will be passed to every neuron on the next layer, right? So here we have three layers, actually two hidden layers. I'll just talk about this. I'll just erase this 1 second, right? So we have this very nice and a beautiful architecture or setup of these neurons. Right, so what are these neurons doing? What is it? So as as we have seen in the last video and the starting of this video, we only have one neuron, right? So what does this neuron do? Well, it just finds a feature in the input data, right? So it will find a feature in this input data that is more important and more likely to affect the output of the model, right? So it is just going to observe and get a feature. But as I told you, in the real world data, the data is not that straightforward. The data has complex features in it that are really hard to identify. And how about we build more a powerful neural network in which each of these neuron work together and will find a feature and find a subset feature, and will find a feature in the data, right? So each of the neuron will find a feature, and finally this output neuron will get will get all these input features and predict the output, right? So let me just elaborate on that. Right, so this is, let's say we have this input, right? So what we'll do is we'll just input all this value will be fed to all will be fed to all the neurons on the next layer, and this input value will also be fed to all the neurons in the next layer. And then what will happen is, will each neuron will have its own weights, w, right? So each neuron will have its own set of weights, right? So here this neuron will have two weights, w1 w2, because there are two inputs, right? And then this neuron will have this neuron will also have two weights, and this neuron will also have two weights, and every neuron and this neuron will have three weights because there are three inputs coming to this neuron. So what will happen is this neuron will compute an output. Now this output is not the actual output, the real output. What will happen is they'll just predict a random number that we humans cannot understand, and that number is said to be the feature, right? So that said number is said to be the feature of the input data, right? So this neuron will find a feature in the input data, this neuron will find another feature in the input data, this neuron will find another feature in the input data, and hopefully they'll all intelligently and beautifully work together to get our prediction. And there is no and there is no change in the way how we input the training data, right? This is the input and this is the output, right? So finally this is the output, right? So we produce o hat. So the output of this neuron is the o hat, right? Okay, understand? And then we will do the same thing. We'll do the loss function, right? After the input goes through all of these neurons, after the input passes through all of these neurons, after all the computations are calculated, after all the features are founded, we'll finally get the output, and then we'll compare this output with the actual output that we would input the model. And then after the loss function is computed, we'll update all of this neuron. And in just a second, in just a minute, I'll just share with you how these weights are updated, right? So these are all weights, right? I'll just share with you how these weights are updated. So yeah, just try to understand this. Each neuron will have its own calculation, and then each calculation of this neuron will pass to every neuron in the next layer, right? So for example, the calculation of this neuron, the feature founded in the data by this neuron will be transferred to all of this all of the neurons in the next layer. And then same with this neuron, the output of this neuron or the feature that it found will be passed to all of this neuron. And what is actually essentially happening is, we are in this these are called hidden layers, by the way. This is called the output layer, right? So yeah, output, this is called the output layer. We have only one neuron, and then these two layers are called the hidden layers. The these two layers find the features in the input data, right? So they find patterns in the input data that are very important, and they are essentially changing this input data, right? So this input data, right, these two input values will be changed into something more important and useful for this output layer to take in and calculate the actual output. So just we can't understand what is happening between these hidden layers, because that is that is a computer that is filling as important features. Essentially that is what's happening in our human brain too. We have the pass of information through these neurons, and we'll try to understand what is going to happening from the input data, right? So these neurons are just finding some valuable features that and these features are just numbers, right? So neural computers just what works with numbers. So they'll just transform this input data into something more useful for the model to calculate the output. So now let's look at how how can this neuron, how can this complex neural network updates, okay, how can this complex neural network update the parameters of each neuron, right? So there are like in actual world there will be many neurons, like millions of neurons. And then if you look at models like GPT-3 and all that, they have like a billion parameters. Parameters are w1 w2, like these are called weights and also parameters. Like GPT has like billion trainable parameters that is when they were training GPT-3, they had the model had to update a billion parameters, right? A billion weights. So now let's see how can we update these neurons. That is also I'll try to cover in the future, because now what you need to learn now is, like, you just have to understand the forward propagation. That is how the output is predicted. Like you just have to understand that each neuron will find a feature in the output, and that in this and this theory will be very helpful to you, and you are especially learning about CNNs, convolutional neural networks, right? uh, okay, so for simplicity purposes, I just drawn a little basic and a little less complex neural network here, right? So we just have like these both of these circles are the input values, right? So we have two input values in this case, and then we have one hidden layer. That is, we have only one hidden layer, that is between the output layer and the input layer. We have only one layer with three neurons, and then we have this output neuron. Actually, let me just draw another layer to understand back propagation. What is happening? How can we back propagation? We use back propagation to update these values, update these weights. We'll see how will we update. How can we update these weights, right? We will see, and then finally, yeah. So let's say I'll just name all these neurons. Let's say this is A1, this is A2, this is A3, this is A4, this is A5, this is A6, and finally this is A7, right? So we'll just go through what is happening here. For example, let's say I want to update the values of weights of A1 neuron. Let's say we have W1. Let's say for simplicity cases, let's say we have only one weight, that is W1. And let's say we want to update this W1 such that the loss function, that is the difference between A7 and the actual output, is as less as possible, right? So we want to see the change. We want to see the derivative of W1 with respect to loss. So I just talked about this notation here, and like 2 minutes or 3 minutes before, right? So we have this dw1 by loss is how this w1 changes this loss, how this w1 affects this loss, right? So we have a special rule in calculus that is called the chain rule, right? So by the chain rule, we can see how one value will affect the other values. I'll just write out the rule here, right? So to update the w1 of the a1, we'll just see. First, we'll calculate the derivative of w1 with respect to a4, right? So we'll just see how this w1 will affect a4, and then we'll multiply that by the derivative of a4 by respect to a7, right? And then we'll multiply that by the derivative of a7 by the loss function, right? So we just calculated this path here, and then what we'll do here, just see what is going on here. First we are calculating the derivative of when we change w1, we are just going to see how this a4 will be affected, a4 being this neuron's output, right? So essentially this neuron's output, this neuron's input depends on this neuron's output, right? So we are just going to input uh, a1's output to this neuron, right? And then, right, so a4, this output of this a4 neuron somehow depends on this a1 neuron also. So we are just going to see how this a4 neurons output will affect a7 neuron output, and then we'll finally see how this a7 neuron output affects the loss. And then we not over, and then we'll calculate how this a1 neurons affect this a5 neuron, and then we're going to multiply with that with a7, and then we're going to multiply with a7, the loss function. I'm just going to write that for your understanding. I'll just say d w1 by d y a 5, then we'll multiply by d a5 by a7, and then we're going to multiply by d a7 by the loss, right? So if you essentially see here what is going on, right? So this a1 contains w1, right? So this a1 has w1, right? So we want to update this w1, we'll calculate all of this process. That is, we are going to see how this w1 affects the output of a4 neuron, because this the w1 neuron affects a1 neurons output, and then this a1 neurons output is going to affect a4 neurons output, right? So we are just going to calculate how this w1, right, so how this weight of this neuron will affect a4 neuron, right? So because as I told earlier, these the neurons, a1's neuron output is going to be the input of a4 neurons uh, output. And then after that we're going to right, so we'll calculate how w1 affects a4, and then we are going to multiply that by how a4 affects a7. Let's say how derivative of a4 by a7, and then we are going to again multiply by how a7 how a7 affects that. We are going to calculate the derivative of a7 with respect to the loss, and then we are going to add that, right, we looked at this path, and then we are going to go with this part. We are going to see how a1, how w1 affects a5, and then we are going to multiply by we are going to multiply by how a5 affects a7, and then so on, right? So we have how a7 affect the loss, and then we are going to do the same with the a6 neuron also. So this is a6, by the way, right? So we are going to see how w1 affects a6, and then how a6 affects a7, and then how a7 affects the loss function, right? So I hope you understand here what is going on. This is called back propagation. We are just going to see how each neuron, uh, right, how each neuron affects each other, right? So how each neuron affects one another, and then that is it. This is for back propagation in today's video. And I also want to talk to you about another main concept, right? So I just want to talk about another main concept, right? So we are going like there are two different main different problems, like two main different problems, actually three, right? I'm just gonna, right, so I'll try to share with you these three type of machine learning problems within supervised learning. So as I told you in the last video, I talked to you about supervised learning, right? So I've talked about supervised learning, what it is actually, right? So in supervised learning, we have the output and the input, and then the model will try to the map between the input and the output, or find the relation between input and the output. So there are actually three different kinds of problems in supervised learning. So the first kind of problem, we are actually going to talk about these two problems for now, and then in the future, maybe in the after 5-6 videos, we are going to talk about the third problem too. The first problem is called the regression problem, right? So essentially, all the things that we have done here, we talked about neural network and all that, right? So that problems are called regression problems. I'll try to talk to you about what is regression problem. The next type of problem is called the classification problem, right? So the classification problem, as the name suggests, we'll try to classify the data into two groups or three groups or anything. Like I'll share with examples. For regression, the problem is the example is house price prediction, right? For example, to predict house prices, you have to predict a number, right? You have to take the input such as the area of the house and maybe the the town of the house, and maybe take these inputs and predict the price of the house, right? But in classify, we have classifying data. For example, detecting apple and banana, right? So in the case of detecting apple and banana, maybe differentiating between apple and banana, we input the images of apple and say to the computer that all of these images are apple, right? So we are just going to give the models give the model the photos are apple, right? So we are going to give a lot of photos, and then we are going to say to the model that these are all the photos of apples, and then we are also going to give the model some photos of bananas maybe, and then maybe ask the model to and just tell the model that these are the photos of bananas. And then what is the model going to do? Well, the model is going to do the same thing. The model is going to have some neurons. It will find each neuron will find some features, and then hopefully it will able to classify images. So this is the problem of classification, right? So if you think about image classification, image recognition, all of these problems come under this classification problem. And the third problem is generative modeling, right? So for example, natural language processing, generating text, speech to speech, generative AI, GANs and all that. We are not going to talk about, for now we are not going to talk about this generative neural networks. We'll talk about that about like after 5 days or that. We are going to do attention mechanism, the architecture used in transformers, or architecture used in chat gpt. We are going to learn about that too, right? So we have regression and classification. So let's see how this classification works, and what are the changes that we have to do. So to do classification, we have something called activation functions, right? So let me just show you the diagram the diagram of the neural network, right? So this is the neural network, right? So we have this output, and then let's say for example we want to classify between banana and apple. We are just going to say to the computer either predict one or zero, right? So we'll just say to the computer that all the uh, we'll just say to the computer that one is apple and zero is banana. So the model will generate one if the model thinks the image is apple, and zero if the model thinks the image is banana. So what is going to happen is we are going to use a function called sigmoid. So what this sigmoid does is the output generated by this neuron, right, is going to be converted within the range of 0 and 1. For example, the model gives us an output of 100, then the sigmoid function is going to take this 100 and is going to convert it between 1 and 0, right? So what will happen is the model will not calculate the derivative only with respect to the loss function, but also with respect to activation function. You will understand it as we go on. Even when I first started, I haven't understand anything, but as we go on, as we try to talk about these topics again and again, you'll understand it, right? So we are going to apply this sigmoid function that is going to transform this the output of this neuron within the scale of 0 and 1. And then this and then the gradient descent will also get used to it and update the neurons based on this output of the loss function. So what this sigmoid function is going to do, the first activation function we are talking about is sigmoid. Next, what is going to do is it will convert the output of the neuron, within the range of 0 and 1. 0 means yes, or 1 is no, or vice versa. Okay, so if, when we are detecting with between two classes, that is we either have the answer as yes or no. For example, we want to build a face recognition application. Maybe ನಮ್ಮ ಯೂಟ್ಯೂಬ್ మా యూట్యూబ్ వీడియో మే చూసుకోండి. సరే 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 అమ్మా. So we have I've talked about this sigmoid function. It is going to, for example, if you want to build a face recognition application, maybe we want a model to like detect my face. Like whenever I input the model my face, it should say yes, and maybe whenever I input the model the face of another person, it should say no. Right. So in that case, we will use this sigmoid loss function to the output layer. That is the output. Right, so the output is going to be at least 0 or 1. Right, so we'll just convert the model the model's output into 0 and 1. And the second type of activation function is softmax. So what this softmax function is going to do is, for example, if you want to build a model, right, so that can classify between let's say 4 classes. For example, let's say you build a model that can detect me and 4 of my friends. Let's say there are 4 persons. Let's say there is person number A, there is B, and there is C, and there is D. Okay, so there are 4 persons A, B, C, D, the names of the persons. Right, so we have photos of A, photos of B, photos of C, and photos of D. We'll try to train the model. Right, what is going to have what are we going to do is, the function of the model is to take an image as the input and detect whether it is the face of A, whether it is the face of B, whether it is the face of C or D. So the model has the duty to detect whether like the model has to detect whose face it is, A, B, or C, A, B, C, or D. So in that case, there is this function. This problem is called multi-class classification, where we have multiple classes or multiple fields to select from. So what are we going to do? What are the changes that we are going to do is, just grab the eraser. So what are we going to do is, rather than having only one neuron in the output layer, right? So we just had one neuron in the output layer, right? We are just going to have here we are going to have 4 neurons. Let's draw these lines. Right, so we are just going to have 4 neurons, and I didn't draw anything. So we in the output layer. So this is the output layer, by the way. We are going to have 4 neurons, and each neuron is going to have its own parameters. So what will each neuron predict is, each neuron will predict. For example, we have A, B, C, D, right? So we have a person A, B, C, D, right? So the first neuron will output the probability of the image being A. So this neuron will generate a number. Let's say it generates a number of 0.2, right? And then this neuron will generate the probability of the image being B. So it generates, this neuron generates how probable, or how probable the image is a B, right? So it will say it just generate a number, right? If the number is higher, then that means that the image is more probably B, right? So now let's say B generates a number of 0.3, and then this neuron generates how probable the model is, the image is C, and then let's say it generates a number of 0.4, right? And then this final neuron D neuron will generate number of 0.1, right? So what is going to happen is, each neuron is going to generate number, right, which says that how probable the image belongs to that class, right? So in this example, the image belongs to C according to the prediction of the model, because the highest number out of all these output probabilities is 0.4, right? So therefore the model is going to select C. So that is the functioning of multi-class classification. And if you can see, the sum of all these outputs will be equal to 1, right? So 0.2 plus 0.3, 0.5, 0.5 plus 4, 0.9, and 0.1 plus 0.1, it is 1. So what is going to happen in multi-class classification is we are going to have n number of neurons, where n is the number of classes or the number of groups that we have to classify from, and then each neuron will be going to generate an output probability on how probable the image, right? So on how probable the image is, the image belongs to that specific class. So thank you for watching, and yes, I'll see you in the next video.